The sine and cosine ratios are two more trigonometric ratios like the tangent ratio. So they work in the same way as the tangent ratio in that they are a relationship between two sides of a triangle. But they're using other pairs of sides than the tangent ratio. So the sine ratio, which we shorten to just SIN, because that's much shorter, this is the ratio between the side opposite the angle you're interested in and the hypotenuse, which remember is the longest side in a triangle. So on an example triangle here, sine theta equals the length of the opposite divided by the length of the hypotenuse. So on this triangle, sine of theta would be A divided by C. The cosine ratio, which we shorten to COS, is between the adjacent side and the hypotenuse. And notice we have now covered all pairs of sides in a triangle. So the cosine ratio is between the adjacent and the hypotenuse, and in this example it would be B and C. Now both can be used in the same way as the tangent ratio to find missing sides or missing angles. So let's look at an example. I've got a right angled triangle and I want to find the missing side. So here's my triangle. And so step one, which should be starting to sound very familiar, is label the triangle. I'm going to label it opposite, adjacent, and hypotenuse with respect to that 68 degrees in the corner. So with respect to that 68 degrees, I set the opposite and the adjacent and the hypotenuse. And then I want to set up the ratio. So the critical thing here is which ratio do we mean? So I'm going to look at what things I have and what things I want. So my sides that are involved are the opposite side and the hypotenuse. The one that uses opposite and hypotenuse is the sine ratio. So sine theta equals opposite over hypotenuse. And now I'm going to replace values with ones that I know. Then, just like with tangent, I'm going to find the ratio on my calculator. So I'm going to find what 68 degrees is, the sine of 68 degrees is on my calculator by pushing sine 68. And I get 0.9272 equals 12.5 divided by x. And now step 4, algebra. Solve using algebra. So the x is on the bottom. I want to get rid of that x on the bottom. I'm going to multiply both sides by x. End up with 0.9272x equals 12.5. And then I'm going to divide by the now coefficient of x, 0.9272. And x equals 13.5. So that missing side, that hypotenuse, is 13.5. Let's try another one. Got my right angled triangle here. And step 1, I'm going to label the triangle with respect to that 30-degree angle. So this is the opposite side, this is the adjacent side, and this is the hypotenuse. Now I'm going to set up the ratio. So I'm going to look and decide which ratio I should use. So I've got the adjacent and the hypotenuse involved. So that is going to be the cosine ratio. So cos theta equals adjacent divided by hypotenuse. I'm going to plug in my known values. Cos of 30 degrees equals x over 15. I'm going to find the ratio using my calculator. So I'm going to punch the cos button, 30 degrees, I get 0.8660 equals x divided by 15. I want to get rid of the fraction. Times by 15, times by 15. And then I'm left with 13.0 equals x. And there's no coefficient of x, so there's no more division. I forgot to write that that's step 4. Algebra! So, to decide which of sine, cosine, or tangent to use, what you want to do is you want to identify which sides are involved, which sides you have or want in the question. So if, for example, you have a number for the opposite and you want to find the adjacent, then you're going to use tangent. If you have a number for the opposite and you want to find the hypotenuse, we're going to use the sine ratio. But if you have the adjacent and you also have a number for the hypotenuse, then that's going to involve the cosine ratio. It doesn't matter if you're saying have or want, but if you're looking for what things you have and or want, which two sides are involved. So let's look at how we're going to solve this involving missing angles. Here's my triangle. Don't get freaked out by big numbers, it doesn't change. Step 1, label the triangle with respect to that alpha there, that angle, opposite, adjacent, and hypotenuse. Then we're going to set up the ratio. So let's look at what sides we have or want. I have a number for the adjacent and I have a number for the hypotenuse. So adjacent and hypotenuse is going to be the cosine ratio. Cosine theta equals adjacent over hypotenuse. And I'm going to put in my known values. Cos of alpha equals 305 over 402. And now I'm going to find the ratio with my calculator. Remember that the ratio in this case is the right-hand side. It's that 305 divided by 402. That's what the ratio is. It's going to give us a decimal number. And for sine and cosine, that will always be between 0 and 1. So 0.7587. And now when we're trying to find an angle, this step 4, we're going to use that -1, that inverse function, to find the unknown angle. So this is a cosine, so I'm going to use cos -1 on both sides, and I'll be left with alpha equals 40.6 degrees. Let's look at another example. Sounding like a broken record, label the triangle. With respect to that beta, that unknown angle, opposite, adjacent, hypotenuse. Step 2, set up your ratio. So I have a number for the opposite and I have a number for the hypotenuse. The thing that involves opposite and hypotenuse is sine. Sine theta equals opposite over hypotenuse. So that means in this case, sine beta equals 14 over 16. That is the ratio, 14 over 16. So I'm going to find that ratio as a decimal on my calculator. I'm going to write it down to 4 decimal places. So sine beta equals 0.875, and that's it, it ends there. Then I'm going to use that inverse function, that -1 or that shift sign on my calculator to find the unknown angle. So I'm going to hit second function or shift, then sine to get to that -1. That will leave me with beta equals 61.0 degrees. Okay, let's give some a try. Try this. Find the missing side or angle. So pause the video, give these 4 a try. Okay, let's take a look. I'm going to label this triangle opposite, adjacent, hypotenuse. The things I have an opposite and I want a hypotenuse, so I'm going to use sine. Sine 32 equals 9 over x. I find the ratio on my calculator to 4 decimal places. Then I do some algebra. I'm going to get rid of that fraction. 0.5299x equals 9. Divide by 0.5299. And I get x equals 16.98. We usually only want 1 decimal place, so 17. Let's look at B. Label that triangle with respect to beta, opposite, adjacent, hypotenuse. I have the hypotenuse and I have a number for the opposite. So opposite and hypotenuse is sine ratio. Sine beta equals 4 over 10. And then I'm trying to find an angle. So I'm going to use that -1, that inverse function. And beta equals 23.6 degrees. Let's look at C. Label the triangle, opposite, adjacent, hypotenuse. Set up my ratio. I want the adjacent and I have the hypotenuse. So the thing that involves adjacent and hypotenuse is cosine. So cosine of 18 degrees equals the adjacent x over the hypotenuse 41. I'm going to find the ratio on my calculator by punching in cos 18. I get 0.9511 equals x over 41. Going to get rid of the fraction by timesing by 41. And I end up with 38.99 equals x, so that's 39. And finally, let's look at D. Label this triangle. Opposite, adjacent, hypotenuse. I have the hypotenuse and the adjacent. The thing that uses hypotenuse and adjacent is cosine. Cosine of alpha equals 4 over 16. Cosine of alpha, then the ratio is 0.25. And I'm going to use that inverse function, that -1, on both sides to undo the cosine and leave me with just alpha equals 75.5 degrees. Okay? So your homework for this section is the sine and cosine worksheet. It is very helpful to write down for yourself which ones are using sine, which ones are using cosine. So side note, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent.